So elementary, where did we were we were an elementary transformation. So we'll just start from there once again so that you are fine on it. Okay, start. This is just a recap of our last class. Elementary transformation. So there are 6 elementary transformations, 3 for the rows and 3 for the columns. You have rows and you have columns. So 3 each. Do you remember? The first one is interchange any row and or any column. So it can be, say you have a row and this row is say row number 3 and you interchange row number 3 with row number 2. This is allowed. Similarly, you can also do an interchange of any column. Say column number 1 is interchanged with column number 3. You are allowed to do this. This is one elementary transformation. The second elementary transformation, do you remember? Multiplying the same number with all the numbers of either a row or a column. Clear? And what was the third one? Third one was subtracting from one row the corresponding elements of another row after they all have been multiplied by a common non-zero element. Okay? So our second one would be something like this, that a row 3 has now been transformed to some k multiplied by row 3. Means all the elements of row 3 will be multiplied by k. So similarly here it can be a column 2 has been transformed after a k has been multiplied with all the elements of column 2. And then comes the third one. The third one is where you have a row 2. A row 2, from row 2 you will subtract what? You will subtract a k multiplied by all elements of row 3 or row 1 or whatever it is. Similarly, you can do column 1 now gets transformed to column 1 minus k into column 2. It can be column 2, column 3, anything. Is this clear or not? Because if this is not clear, you won't be able to do inversions. Okay. Our next topic is invertible matrices, where we will try to find the inverse of a matrix. But you will get this repeated again when you will be doing determinants. So now you will be doing inverse of a matrix by only elementary transformations on the matrix itself. Shall we? Can I go ahead? Okay. Our next topic is invertible matrices. Invertible. And this is the last topic. What does invertible matrix mean? So it defines very nicely. If A is a square matrix, children, this section of the top of the chapter deals only with square matrix. It cannot be any other matrix. Square matrix, and suppose its order is M, right? Its order is M. There exists another square matrix of order M called B. So if A is a matrix, there exists another square matrix of order M called B, such that whether you multiply A with B or you multiply B with A, you will get an identity matrix. And what is an identity matrix? It will be the same square matrix of the same order with the diagonal elements as 1. Understood? Okay. In that case, in such a case, B is called the inverse of A and is written as A inverse, or A can be also called as the inverse of B. Then A will be known as B inverse. So a matrix multiplied by its inverse will always result in the product diagonal, in identity matrix, same order. Just this is absorbed. If you have a square matrix of order m, then there will always exist another square matrix of order m, which is B, such that AB will be equal to BA, which will be equal to identity matrix. Let's see some examples first, and then we proceed for finding out inverses. Let's see an example. So our example is A is a matrix which is 2, 3, 1, 2. Okay, and B is a matrix which is 2, negative 3, and negative 1, 2. Try to find out what is AB. How do you calculate AB? You will multiply the columns with the rows. So let's take the columns. 2 multiplies with 2 and 1 multiplies with negative 3. Similarly, 2 multiplies with negative 1 and 1 multiplies with 2. Similarly, 3 multiplies with 2 and 2 multiplies with negative 3, and here 3 multiplies with negative 1 and 2 multiplies with 2. So let's see this. AB. So 2 into 2 is 4 and this is 3. So the 4 minus 3 gives me 1. 2 ones are 2, minus 2 and plus 2 gives me a 0. Then 3 into 2, 6 and 6. This will give me a 0 and this gives me again 1. Clear? So in this case, we will call B can also be written as A inverse. For assertion reasoning, remember, rectangular matrices cannot give you an inverse matrix. Inverse matrix is always a square matrix, and if B is inverse of A, then A is also the inverse of B. So A can also be written as now B inverse. Have you understood this logic? B can be written as A inverse or A can be written as B inverse, because the product AB or BA, whatever you are doing, you are getting as I. Then there is one very interesting observation, that the inverse of a matrix is unique. Unique means, children, you cannot have another matrix which will satisfy this criteria. There is one and only inverse. So what we said, if B is the inverse of A, you can't create another matrix C which will also give you an identity matrix. So there is only one inverse for a particular matrix. There is no. Ananya, understood this? There is only one inverse. It is unique. And further, another is AB product's inverse is same as B inverse into A inverse. AB inverse is B inverse into A inverse. So let's quickly finish it. Invertible matrices. So this is what you know. Given a square matrix of order M, given a square matrix, say A of order M, there exists a square matrix B of same order such that AB is equal to I, or BA is equal to I. In such a scenario, B is called the inverse of A and vice versa. B is called the inverse of A and vice versa. So we have invertible matrix theorem, which says if A and B are invertible matrices, now there is a small catch. I hope you all have been able to understand between these two. Children, what we have written here, it says B is the inverse of A. Here the criteria is not that B is inverse of A. You have picked up two invertible matrices. What is an invertible matrix? A matrix whose inverse exists. As per this statements, A is the invertible matrix. Why? Because for A you found somebody B, with which if you multiply A you get I. Here A and B are not inverse of each other. A is an individually invertible matrix, B is an individually invertible matrix. Is this clear now? If A and B are invertible matrices, but the criteria is that they are of the same order, then in that case we say that AB inverse is B inverse A inverse.
Sir,
Yes, sir.
does there exist matrices that aren't inverted?
Yeah, any rectangular matrix will not have an inverse.
Do they exist square?
Some square matrices will be invertible. Square matrices will be invertible. That if you have a square matrix, but again, the square matrix will be invertible and its inverse will be of the same order. However, there will be one and only unique inverse of a matrix. What we are talking here is that suppose you found A as a matrix which is invertible and B as a matrix which is invertible. Not that A and B are inverse of each other. Then in that case, the inverse of the product of two invertible matrices is same as inverse of B multiplied by inverse of A. Fine.
In the first case, it's necessary that A and B are.
No. In the first case, no. You got it wrong, Ananya. In the first case, we are trying to explain you what do you mean by an inverse of a matrix. Okay, so see, look at me. What do you mean by inverse of a matrix? Suppose you have a square matrix A whose order is M. M means a M by M square matrix. Then there will exist some matrix B, C, D, E, some matrix which is also a square matrix, also of the same order. And if you are able to prove that the multiplication of both is giving you an identity matrix, then that other matrix which you found is the inverse of this matrix. That is the definition. What is, if I am a matrix, what is my inverse matrix? My inverse matrix multiplied with me gives an identity matrix. Here I am saying, now that you have understood what is an invertible matrix, you went to the shop and you bought two invertible matrices. A's inverse is A inverse, maybe some matrix D. B's inverse is some inverse B inverse, which is some matrix E. If you take two invertible matrices and you find their product's inverse, that is same as B inverse into A inverse. This proof we will see. Okay? Now the first step, it says by definition of invertible matrix. What is the definition of invertible matrix? A matrix multiplied by its inverse should always be equal to identity matrix. Fine. There's something that you have to mug up. Now multiply A inverse on both sides. AB into AB inverse gives you A inverse I. Fine. Now next step. Look at the right side. A inverse on I will give you A inverse. Is this understood? Any matrix multiplied by the identity, that's why you call it identity matrix. It will throw the same matrix. Multiply A inverse with A and multiply B with AB inverse. A inverse into A will give you an identity matrix. B into AB inverse is A inverse. Identity matrix multiplication does not change anything. So it retains as B into AB inverse is A inverse. Fine. Now bring B inverse on both sides. B inverse B into AB. Your job is done now. You're done. B inverse A inverse. Now B inverse into B will give you what? Identity matrix. Identity matrix into AB inverse B inverse A inverse. Identity matrix does not change the matrix. AB inverse is fine. Okay, stopping the recording a bit. Let's do this. It says, this is a miscellaneous example, all a test of patience problem. Let A equal to 2 minus 1, 3, 4. Ananya, just mute your mic a bit. I think there's a noise coming. Okay, then B is equal to 5, 2, 7, 4, and C equals to 2, 5, 3, 8. Find a matrix D. Find a matrix D. Such that CD, this is all equation problem. CD minus AB is equal to 0. Okay. So let D be equal to, you give anything in D, A, B, C, D. This is D. So that, and then we will compare terms. Ready, children? Can you do CD first? Let's perform CD as an operation. CD. Achha, what does this mean? This means beta CD should be equal to AB. So what we will do, look, don't look at the book. We'll do CD first, we'll do AB, and then we'll compare terms to terms. And we'll get the values. Ananya, did you understand this? Pretty easy, unless we goof it up. Okay. And don't look at the book. Let's do CD. CD is 2 minus 1, 3, 4. Yeah, have energy. This is
It's negative.
okay. This is my third class. I'm still having energy left. Okay. C into D. D is what? AB, CD. How do we multiply? Neha, row into column into row. So column into row, 2 into A, right? Plus 3 into B. Fine. 2 into C plus 3 into D. Then minus 1 into A plus 4 into B. Then minus 1 into C plus 4 into D.
Sir, we're doing 5 we're doing CD, not A. This is what you just did, A.
Oh. Yeah. Sorry. Oh, this is CD. I'm so sorry. No, sorry. C. Okay. 2538. That is being multiplied with A, B, C, D. Fine, no issues. So we get 2 into A plus 3 into B, then 2 into C plus 3 into B, then 5 into A plus 8 into B, then 5 into C plus 8 into D.
What if we do it just
2A. No, I'm going this way, na? Rows into columns. Columns into rows. 2 into A plus 3 into B. Then,
3?
wait 1 minute. I'm booked up yet.
Like I'm doing it.
You're multiplying this. This is column multiplied by the rows, right? That's what. If you take the column, you'll multiply the row. How are you going? We are supposed to do CD multiplication. So this is C.
He's using you're using 2 and 3.
No, you cannot go by this one. You are doing this with this. So you are doing row into column, you say.
Yeah.
See, keep one thing always in mind. Do not concentrate on this matrix. Keep one thing in your mind. You're multiplying. How are you multiplying? You're using this row into this column. Right? Never say this one into this. That will goof up the whole problem. So you say, I'm multiplying 2, 5 with AC. Make sense? Chalo. Solve it further. Done. Okay. Now we will do AB. Fine. So 2b plus 5d is equal to 0. And 3b plus 8d is equal to 22. Crisscross multiplication. And how to solve this? Take its exponent and multiply both sides. So if you multiply the first equation by 3, it becomes how much? 6b plus 15d is equal to 0. Multiply this with 2. So this becomes 6b plus 8 2s are 16d is equal to 44. Then subtract. This goes away. 16d and 15d is negative d is equal to negative 44. So d equals to 44. This is one equation we found out. Right. Yeah, 44. D is equal to 44. Then, if D is equal to 44, you can find out what is the value of B. So, 2B is equal to negative 5D, or B is equal to negative 5 into 44 divided by 2. So, that's 22, right? So, B's value equals to negative 110. Then 2a plus 5c is equal to 3, and 3a plus 8c is equal to 43. So multiply this with 3. This becomes 6a plus 15c is equal to 9. Multiply this with 2. 6a plus 18c is equal to 86. Subtract, subtract, subtract. So we get negative 3c is equal to 86 minus 9, 10, 76. 9 is 77. Negative. Something wrong, I think. C equal to 77 by 3. They've got C as 77. How much is this? 2a plus 5c, 2a plus 5c, and this is 3a plus 8c. That is correct. 3 and 43, 3 and 43. Where did we go wrong? No, no, this thing is correct, beta. Which one? This is absolutely correct, huh? This is correct, and this is also correct. No questions. Which one? 6, 6c. This is 16. So it is negative c equal to 77, negative 77. So c is equal to 77. Thank you. So c is equal to 77. Correct. We can be wrong every time. C is equal to 77. Even this is fine. Now you need to find out the value of A. So A is equal to 9 minus 15 into 77. And this, Neha, you will do for me. 9 minus 15 into 77 divided by 6. So make it small. So if you take out 3 as common, this becomes 2, this becomes 3, this becomes 5. This is the least we can do. So A's value is equal to 3 minus 7, 5, 35, 5, 3, 7, 5, 35, 38, 385 divided by 2, which is equal to negative 382 by 2, which is equal to negative 191. Negative 191. Yes. Yes, we are correct. We're correct. We're correct. We're correct. We're correct. We are correct. All you need in these problems are patience. Patience is the most important virtue. The more patience you have, the more you will be able to solve. And these questions are very common.